Hi everybody, welcome back. Today we're going to be talking about writing equations in vertex form. Now, just like when we were looking at linear functions and we had all those different forms that we wrote the same linear function in, such as slope-intercept form, point-slope form, standard form, well, quadratic functions are the exact same way. So we can take a quadratic function and we can write it in a number of different forms. It's the exact same quadratic function, you're just seeing it a little differently. And each one of these forms is highlighting something special about that particular function. So in today's notes, when we're writing equations in vertex form, we're going to be using what we did yesterday, where we're going to simplify our quadratic using the complete the square method. And on top of that, we're also going to be identifying the vertex of the quadratic, which remember is the turning point. We're going to be able to identify the vertex just by looking at the equation. We won't have to graph it. So let's go ahead and get started here. You'll notice on top there's two different ways that we've written vertex form out for you. You'll notice one of the ways you'll see A, B, and C. The other one you'll see A, H, K. X is in there both times. But these are just some ways that you might see a very general form for vertex form of a quadratic. So B and C, so if we're looking at the first equation, B and C here are really important. And the reason for that is B and C actually provide us with the X and Y value of the vertex. Just like in the second equation, H and K end up giving us the X and Y value for our vertex. So once we get our equations in vertex form, or once we simplify them using complete the square, we're going to be able to pick out the vertex very, very easily. So let's get started. Looking at number one, we're going to use completing the square to write the quadratic equations below in vertex form and then identify the vertex from it. So if I'm looking at number one, remember yesterday we never worked across an equal sign, really because we didn't have one there. So we're going to assume that the same thing is going to happen today. We are not working across an equal sign. We're keeping everything on one side of our equation, and we're going to use the complete the square method this way. So if I'm looking at question one, I'm going to start by rewriting this. I'm going to say y equals, and I'm going to put in parentheses, just like we did yesterday, the x squared and the minus 6x. And then I'm going to say plus blank. Now that blank, again, remember, is a value that we're going to fill in that's going to make what's inside my parentheses a perfect square trinomial. So this plus 8 ends up going outside my parentheses now. We kind of kicked it out for a little bit. And that value that we're going to add inside the parentheses, we're going to subtract on the outside. Because again, we're not trying to change this original quadratic. We want to keep working with this quadratic. We're just going to make it look a little different. Okay, so what is that value that we're going to fill in? Well, let's look at our B. So B is negative 6. I'm going to half this value to get negative 3. Then I'm going to square negative 3. And I get 9. So 9 being a perfect square, I'm going to put that in to the space provided, and I'm going to work with it. Now, taking what's in parentheses and factoring it, remember we want to find factors of 9 that add up to negative 6. All right, well, negative 3 and negative 3 are going to do that for me. And then simplifying what's on the outside, I get minus 1. Remember, the whole point of perfect square trinomials is to get the exact same factor inside our parentheses. That's why we do this work. All right, so simplifying a little further, x minus 3 times x minus 3, I can simplify to x minus 3 squared, and that minus 1 stays on the outside. Now here is vertex form of a quadratic. You'll notice a couple things. First, if we take a look at the factor that's inside our parentheses, this negative 3 here, notice that negative 3 was also present when we took half of that original b value. This should be the case every single time. So when you take half of b, that should end up being your factor inside the parentheses. Now, this negative 3 also happens to go along with this b value, or h, depending on which equation you're looking at here. It also happens to go along with that value inside our parentheses in vertex form. This value represents the x value of our vertex. So x minus whatever that value is, x minus 3. So our vertex has an x value of 3. The y value comes from this value that's located on the outside of our vertex form, which is negative 1. Now, negative 1, we're just going to write in as we see it. And we are all set. Now, if you want, what I did is I was going through these originally is I was checking with my calculator every time I did a problem. So if you want, take a moment, pause the video, and type it into your calculator and go ahead and check for where the, in this case, minimum value is. You should end up with 3, negative 1. That might be good practice as we go throughout these questions. All right, let's try number 2. Now, number 2 is a little bit different. Notice how we have this negative 3 in front of our x squared. So we're going to have to be really, really careful with this. So just like yesterday, we're going to get started by taking that negative 3 out. And when I say that, remember, we are not working across an equal sign. We're not applying any equality properties here. So by taking the negative 3 out, we are factoring it out as a GCF. It's not going to go anywhere. It still is going to be present in our actual equation. There we go. Okay, it doesn't disappear. All right, remember, we did not use an equality property here where negative 3 could go away. It stays put on this right side, just outside of our parentheses right now. Okay. So now let's take a look inside. Now we're going to do all the work that we did in the previous problem. Now, just to separate this negative 3 a little bit more, I'm going to put brackets here for a second. Okay. And now when I put in my parentheses, x squared minus 8x stay in, plus blank. I'm going to close that parentheses. On the outside, I have plus 9 minus blank. And here I'm going to close the brackets. Now, the reason I'm including the brackets is technically that negative 3 was taken out of every single term on this right side. So if we wanted to put it back in, we have to distribute to every single term that was inside that original parentheses. And in order for us to keep including this plus 9 out here, we have to use these brackets because we don't want it to be forgotten about. So now let's figure out what's going inside that space. Alrighty, so taking my b value, so not the original, we're going to take the b value after we took out the GCF of negative 3. So we're going to use negative 8 here. So negative 8, we're going to half it to get negative 4. Remember, this becomes our factor, and then we're going to square negative 4. And that's going to give us 16. All right, so working with 16, I'm going to add 16, subtract 16. All right, continuing on here, the negative 3 stays on the outside. And now I'm going to factor what's inside parentheses here. Remember that negative 4 ends up being the value inside my parentheses. 9 minus 16 gives me negative 7, and I'm going to close my bracket here. Now, just to make this look a little nicer, I'm going to redistribute that negative 3 to the 2 terms that I have inside the brackets. Now, one of the terms is x minus 4 squared, and the other term is this minus 7. So if I distribute that negative 3 to both of these terms, I end up with negative 3 times x minus 4 squared. Remember, you shouldn't be taking that negative 3 inside the parentheses. All right, order of operations says multiplication comes after the exponent, and we did not do anything with that exponent right now. Negative 3 times negative 7 gives us a positive 21, and here is vertex form of this equation. Now, what is the vertex in this case? Well, looking at the vertex, remember I'm going to use the value that's inside the parentheses and the value that's outside the parentheses. So inside the parentheses, x minus 4. Okay, so that 4 is my x value of the vertex. My y value is a positive 21. Okay. All right, let's move on to number 3. Practice, practice, practice. All right, so number 3, same thing. We have this 2, this a value of 2 in front. We are going to have to GCF factor that out. So when I do that, the 2 comes in front, and then x squared minus 3x plus 2 stays inside the parentheses. All right, so ignoring the 2 on the outside for a second, I'm going to focus on what's going on inside the parentheses. Let's complete the square with what's inside the parentheses. So y equals, again, leave the 2 on the outside. I'm going to use brackets here to help me separate everything. Inside the parentheses stays x squared minus 3x. I'm going to be adding some perfect square here in just a second. The plus 2 comes on the outside, and minus whatever that perfect square is going to be here with a bracket at the end. All right, so using b is negative 3. Half it gives us negative 1.5. Square it gives us 2.25. Oops, sorry. I'm touching the screen in different spots, so it's causing all sorts of lines to come up. Alrighty, so plus 2.25 minus 2.25. Remember, we're trying to keep this side of the equation balanced. That's why we add inside the parentheses, subtract on the outside. All right, so here is where us knowing that this value right here is the factor, or is the number that should go inside our parentheses, is really important. All right, because we're not used to factoring when we have decimals here. So knowing that little trick, when I factor this, I should end up with x minus 1.5 squared. 2 minus 2.5 is going to give me minus 0.25. Okay, so just to simplify this a little bit more, to make it look a little nicer, let's distribute this 2 back through. Remember, I'm going to multiply this whole term by 2. Do not go inside the parentheses. You are not allowed to do that. And I'm going to multiply the negative 0.25 by 2 as well. So completing this, I get 2 times x minus 1.5 squared minus 0.5. So here is what we would call vertex form of a quadratic, and then identifying the vertex, we're looking inside here and outside here. So 1.5 comma negative 0.5. And again, go ahead and check with your calculator, make sure we're right, and move on from there. Okay? All right. Let's now take a look at number 4. Okay, one more practice, just to make sure we're feeling really confident with this. Alrighty, no a value this time except for 1, and that's okay, we can work with that, not a big deal. So rewriting my quadratic here, I get x squared minus 12x plus blank, and then I'm going to move that 20 on the outside of the parentheses minus blank. So plus blank minus blank, keeping our equation balanced here on the right side. Okay, what are we filling in with that blank? So b is negative 12. When I half it, I get negative 6. Sorry about that. I'm trying to get too close with this thing. Okay. All right, so half it, square it. So half it is going to be negative 6. Squared is going to be 36. So I'm going to add and then subtract 36 here. Alrighty, factoring what's inside my parentheses, I get x minus 6 squared, because remember when I took half of b I had negative 6. 20 minus 36 is minus 16. So here is vertex form of the quadratic that we have in number 4. So it's the exact same thing. It's the exact same quadratic, just written a little differently. And 6, negative 16 is our vertex. Now, if we had, so this is completely separate here, if we had something, let's say instead of x minus 6, we had x plus 6 squared minus 16 inside our parentheses here. If this was the case, and I asked you to identify the vertex, this value right here, this x value, remember, in our original equation, we had x minus h, or x minus b. And that h and b, if we go back up here, this h and b represented the x value of our vertex. But now, instead of x minus that value, I have x plus that value. So that means our x value of our vertex is actually a negative 6, because how did we end up with that plus? We would have had to take minus a negative value, and this negative value right here ends up being the x value of our vertex. So if, one way if you want to think about it, you're taking the opposite of what you see inside the parentheses. You see this positive 6 here, the x value is negative. You see this negative 6 here, your x value is going to be positive. So it's always going to be the opposite what you see inside the parentheses. All right, let's go to the back and let's do just a nice review of a lot of different things that we've learned so far when it comes to quadratics. So this again is called factored form. So again, just another form for us to remember. So far we have factored, we have vertex form, and standard form. All right, so here's factored form. Now factored form gives us the x-intercepts. So if I set y equal to 0, and I start solving for x here, I know most of you could do this in your head. I'm just trying to show you what work we would expect to see. You would see x minus 5 equals 0, x minus 2 equals 0. We're applying the 0 product property here, and we get x equals 5 and x equals 2. So your x-intercepts, you could leave them like this. You could write them as a point, 5 comma 0, 2 comma 0. It's up to you. Both of these are acceptable. All right, let's rewrite this equation in standard form. We can do that. So let's take our factored form and FOIL. Okay, first, outer, inner, last. X times x is x squared. X times negative 2 is negative 2x. Negative 5 times x is negative 5x. And negative 5 times negative 2 is positive 10. Simplifying and combining like terms, I get x squared minus 7x plus 10. So this is just another way to write the quadratic that we listed above. All right, what is the y-intercept in this equation? So in order to get the y-intercept, we're going to set x equal to 0 and solve for y. So y equals, and you can do that in either form. You can do that in factored form or in standard form. Either one is fine. I'm going to use standard form just because it's probably going to be a little bit quicker here. If you use factored form, we would still come up with the exact same value for the y-intercept. All right, 0 squared is 0. 7 times 0 is 0. And you see we're left with 10. So standard form tells us the y-intercept, if you notice, without having to do any work. Because look at, the y-intercept was right here. Factored form gives us the x-intercepts, which are right here. Okay? All right, let's keep going. So, continuing on here, we're going to rewrite the equation in vertex form. All right, so using standard form, we're going to do what we did on the page before. All right, so I'm going to take the x squared and the minus 7x, those stay in the parentheses, plus blank, plus 10, minus blank. All right, half of negative 7 is negative 3.5. Negative 3.5 squared gives me 12.2. 12.25. Okay, so I'm going to add 12.25, subtract 12.25. Now, half of b was negative 3.5, so that's going to be the factor inside, that minus 3.5 squared. And then 10 minus 12.25 is minus 2.25. All right, so we're looking good. Here is our vertex form of that quadratic. And remember, the vertex comes from that value inside the parentheses as well as the value outside the parentheses. So our vertex is 3.5, opposite what we see. And then negative 2.25. That guy stays the same. We don't change that one around at all. Okay? All right, so moving on. Is our parabola going to open up or down? Well, check the a value. Check the value that's attached to x squared. What are we thinking? Looking at our standard form for the equation, that a value is a positive 1. When it's positive, we're happy, we're smiling. Our parabola is going to open up because it creates a smiley face. So positive a value. All right, find the discriminant. So you guys did this the other day. So the discriminant is square root b squared minus 4ac. Okay, and actually, when it comes to the discriminant, do we even need to worry about that square root part? We do not. We're only focusing on the b squared minus 4ac. So I'm actually going to take that guy out. Okay, we're only focused on the b squared minus 4ac part here. Okay, so plugging in the values, I know that a, if I'm looking at my standard form here, a is going to be 1, b is negative 7, and c is 10. Okay. A is 1, B is negative 7, and C, why does it keep doing that? Hang on one second. Sorry, people. Bear with me. All right. Okay, I don't know why it's doing that. All right. So B squared, negative 7 squared, minus 4 times A times C. All right, so this gives me 49 minus 40, which gives us 9. This is a positive value. Remember, we said when it's positive, describe the nature of the roots. Well, we're going to end up having real roots, not imaginary. And how many in this case? We're going to have 2. Okay? So this positive value says we're going to have real roots. How many of them? We're going to have 2. Okay, so let's go ahead and actually graph this parabola using the features that we know. All right, we know that the vertex is at 3.5, negative 2.25. Our y-intercept is 10. Now I'm just noticing on this graph, we do not have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. All right, so I'm going to go up by 2's. Okay. 6, 8, 10, 12, 14, 16. Y values, we can go up by 1. We shouldn't have, or I'm sorry, x values. X values, we can go up by 1. Y values, we're going to go up by 2, and we should be okay. At positive 3.5 for my x value, I am going to draw in the axis of symmetry. Now for my folks, we just kind of put that dotted line down. So this, again, it reminds us where, and actually, I'm going to try and make this a little nicer. This reminds us where our graph is going to be cut in half. Okay? So right here, y, guys, we're going to get this. Okay? We're going to figure this whole thing out. I promise. Bear with us. All right, so at 3.5, here's our dotted line. Just try and make it look a little nicer. Again, it can be subtle. It doesn't have to be anything crazy. It's just reminding us where our graph is cut in half. All right, so 3.5, negative, so negative 2. Remember, my y values are going up and down by 2. 0.25. Eyeball that the best you can. We've got x-intercepts at 5 and 2, a y-intercept at 10. Okay. So a y-intercept at 10, x-intercepts at 5 and 2. Now I can also come, since we're talking symmetric here about this line, I'm going to go 1, 2, 3.5. Okay, a half, 1, 2, 3. I know that there should be another point here. You can also feel free to use your calculator if you would like to grab a table of values to help you. Oh goodness, I kind of missed that one there, sorry. All right, so there is our quadratic. Hopefully yours looks a little nicer.